Hello, Mysuru. Thanks, Uta, and all the organizers of the event for this opportunity. I am Anubhav Singh. I'm the co-founder and CTO of DynoPy Inc. and been involved with cloud and machine learning for a long time. I also am the lead organizer for GTC Cloud Kolkata. Now, quickly moving on to the topic, let's discuss the problem statement. For over 100 years, the New York Times archived almost like more than 1 million photos, and all these photos were stored in their basement, and they were stored in these hundreds of cabinets, which was not really possible for everyone to remember even which photos were with them. And these were historical photos, right? So these photos were really important, and some of them do not even have a second copy. And the problem statement was that we wanted to digitize all these images so that in case of any kind of physical failures, we do not lose this invaluable photographs, right? So if you look at the photographs here, um, on the left side you see the photograph, and on the right side it's the back side of the photograph. And while it is not really possible to understand from the front side what it contains, the right side has a lot of information about say when the photo was published in the newspaper, in where has it traveled to, and the information that is contained in that, right? So a summary of the problem is that there were a million photos in the NYT archives, and these needed to be stored digitally. The photographs should be accessible via search, and any information inside them. Associate any information present on the back of the photograph with the image, like a kind of a metadata, and if possible, draw insights from these images, right? So let's break down the problem very quickly. And to break down the problem, let us think about the steps that will be needed, right? So the first step would be to store the images. Then we'll be sending them for processing. This processing will involve two parts, right? So this processing first involves that the image should be transformed in a way that it is usable by the further algorithms. And then there will be the extract visual information, which means the computer vision algorithms, which will be extracting data from that image, right? And finally, when you are done, we'll have to store the extracted information in a search-friendly index, right? So that we can very quickly search through it. That if we wanted to find a photograph of a station, maybe a photograph of World War II, we should be able to do that with just specifying the minimal number of queries. So let's design the solution. Let's think about what we'll need, based on the steps that we discussed just now. So the first thing we'll be needing is to store the images, and for that we'll be using Google Cloud Storage. And this is actually the solution which was implemented by New York Times and Google Cloud back in 2018. So we are going to talk about what they used back then. And after storing the images, we need to trigger that, hey, there are new images in the database, let's process them, right? So we need a trigger, and for that, PubSub will be used. And PubSub basically sends a signal that, hey, this new image has come in, let's send this for processing, right? And the first step of the processing, as I mentioned, it actually goes to a GKE cluster, which does image resizing, transformations, whatever I needed for making it better suitable for computer vision algorithms later on at the next stage. And then for computer vision, we use the Cloud Vision API. Initially in 2018, when this solution was implemented, it was known as Google Cloud Vision. Now it is Cloud Vision API. And finally, we store the database. We store it to the database Cloud Spanner in the form of a Postgres database. So if I put on the architecture of this, this is how it looks. The data first starts from cloud storage, triggers PubSub, goes to GKE cluster for resizing and other manipulations, then goes to Cloud Vision, and finally the data is the information extracted from the image is stored in Cloud Spanner. And so this was a very efficient flow of the system to digitize all the photographs that they had, and they had huge success with it, right? So if you wanted to build something like this today, you would be using tools that are available today, right? And while all the tools which we talked about in the previous slide are still available, they have been simplified, right? If you see the number of steps that are required here, And if you look at the number of steps that are required by document AI, is this document AI replaces the kind of the three steps in between, right? PubSub, GK, and Cloud Vision. It kind of replaces all these three, and we'll be looking how. Right, so this is what Document AI does. It's an end-to-end pipeline for processing document data, and it has pre-trained models available, which you can use to extract information from different kind of documents, not just images. It could be forms. It could be pretty much any document that you can think of, which has data in a any kind of fashion. And you could also choose to train your own models. So in case the document that you're working with is not available in the pre-trained models, you could definitely make one of your own. And finally, there's the warehouse where you can just store the documents and you like quickly search over them, right? So let's try it out. Let's see how Document AI can help us. Here for the demo, let's explore how Document AI can work with the documents that we give to it. And initially, it asks us to either explore processes or create a custom processor. A processor is basically an end-to-end pipeline of a document that is coming in and then getting processed. So you could choose to do something which is predefined, or you could choose to create something of your own. And these are the multiple options which you have available. There's like a number of them. And for us, it will be very simple because we are going to use something which is like this, and this is an image of a book, uh, which I've downloaded straight from Google Books, and we just need a document OCR, so we'll just do a book processor here, and let's go with the default region. We have created the processor. It hardly takes any amount of time to create this. Now we will just upload the test document, which is the same page which we saw here, and it says it's analyzing the document. Let's see, and it has taken out all the paragraphs from this particular document, right? So it has recognized pretty much every text which is available on this page. And after you are done taking out the text, it is up to you how you use it, how you store it, and how you want to transform this. So that was for the demo. Right, so after the demo, let's very quickly look at the resources that you have available for if you wanted to study more about this. And these are the resources which I'll recommend very quickly. The first link actually refers to the article published by Google Cloud Blog on how they helped New York Times archive their images. Then there's the link about Document AI, and finally, there's a Google Developer cheat sheet, which probably is one of the most invaluable resources out there. And finally, let's connect. If you want to get connected with me, hit like just scan that QR. And if you want to get the deck, the presentation which I made just now, just scan the one on the right. So thank you, thanks a lot, and it has been great talking to all of you.